Good afternoon, everyone. I would request everyone to settle down for our next session. First, I would like to thank Dr. Swaren sir and all the esteemed panelists. That was indeed an extensive and informative session on green steel upgradation and technology. With this, now let us move towards our next session, and that is reducing carbon emission, combined electrification, and clean hydrogen. Dr. Vishwanathan Nurni is the Sajjan Jindal Steel Chair Professor and Head of the Department of Metallurgical Engineering and Material Science at IIT Bombay. With over 2 decades of teaching and research experience, his work spans process metallurgy, blast furnace operations, steel making, and iron ore agglomeration. A distinguished academic, Dr. Nurni holds a PhD in metallurgy from ISC, Bangalore.
Very good morning to all of you. First of all, I would like to thank MRIA and especially Mr. Pramod Shinde for giving this opportunity. I think probably I am the only academician here in this gathering. Of course, now I see the last 4-5 years I have been attending such gathering. That also shows the industry as well as academia are coming closer and closer, and that is very important to create the ecosystem of innovation in the country. This particular the panel discussion session is reducing carbon emissions, combined electrification and clean hydrogen. That is the panel discussion we'll have. So we have a very distinguished panelist. So let me call one by one. So I would like to call upon Mr. Ashwini Kumar Bhatia, Managing Director, ARS Steel and Alloy International Private Limited. Welcome, sir. Mr. Ashwini Kumar Bhatia, Founder and Managing Director of ARS Group of Companies Limited, is an economics honors graduate with nearly 4 decades in the steel and trade industry, starting with Mill Street Scrap Trading in 1978. He founded ARS Steel Private Limited in 1990, growing it into a leading steel producer recognized for quality, sustainability and innovation. Welcome, sir. Next, I would like to call upon Mr. Keyur Shah, Managing Director, Mono Steel. Mr. Keyur Shah, Managing Director of Mono Steel India Limited and Director at MRAI, leads one of the Gujarat prominent steel manufacturers producing steel bars, bright bars and MS bars. Under his leadership, the company champions sustainable steel making and responsible recycling practices in the Indian steel industry. Welcome, sir. Next, I would like to call upon Mr. Rohit Agarwal, Project Head, Steel Recycling Business, JSW Steel Limited. Mr. Rohit Agarwal, Project Head, Steel Recycling Business at JSW Steel, has over 15 years of experience with leading steel companies. He has played a key role in decarbonization efforts and scrap supply chain development, driving growth sustainability in the Indian recycling industry. Welcome, sir. Next, we'll have Dr. Arathi Bhosle, Director and Founder of Greenex Environmental. Dr. Arathi Bhosle. Yeah. Welcome. Dr. Arathi, Director and Founder of Greenex Environmental, has over 15 years of experience in sustainability, life cycle assessment and carbon and water footprint studies, a PhD researcher in wastewater innovation. She holds certification from IGBC, Griha, LEED and C2 as carbon, CII as a carbon footprint professional. Welcome, Dr. Arathi Bhosle. Now, I also would like to call upon Ms. Amrita Kanderkar, steel market reporter, Argus Media. Welcome. So Miss Amrita, steel market reporter at Argus since 2024, covers pricing and news on Indian domestic finished market. Previously a financial market reporter with Reuters. She holds a master's degree in journalism from Symbiosis Institute of Media and Communication, Pune. So, welcome once again to all the panel members. So, let us start the panel with a presentation. So, first I would like to give a brief presentation just to give my views, and then followed by the panelist who wants to give a presentation. So, first a small presentation from my side. So, of course, just to tell you, I belong to the Center of Excellence in Steel Technology at IIT Bombay. Just to tell you, IIT Bombay has been pioneer when it comes to iron and steel making. You know, we have more than 25 faculty members working in this field. And we are also, especially knowing the needs for the country in terms of steel, you know, especially if you want to have the dream of, realize the dream of developed country, steel is going to play an important role. We all know that. So hence, IIT Bombay has made sure that there is sufficient expertise when it comes to steel making. So that is the thanks to Ministry of Steel that we established 2014, the Center of Excellence in Steel Technology. And with that, we have been, of course, working with all the major steel plants so many years. And of course, now last 3-4 years, IFA, now SIMA, and also MRI, they are all also working with us, started working with us. And we are also having a new building. Just I would like to tell you that JSW has contributed steel towards that building. So that will be this whole steel center with the state-of-art facilities will be hosted in that particular building. So that way, we do a lot of work with the iron and steel sector. So can we go to the next slide, please? Yeah. Can I? Oh, sorry. Yeah, sir. Yeah. So we all know about the Indian steel production versus consumption. Okay? And this is the current picture. I think Dr. Swaren did mention about some of these things. And we also know very well about the unique sector which we have in India, where 40% of the steel is produced by relatively, small and medium sector, and lot of steel is also produced by the large integrated steel producers, primarily from the iron ore. And we are the second largest steel producer. That is also well known to all of us. And on one hand, if we want to produce by 2030, we wanted to reach some 300 or so, and then 2047 or so, 500, etc. These are some of our goals. But at the same time, we have also, when it comes to emission, we have also signed some of the, world level agreement where we want to actually reduce the carbon emission. So on one hand, we want to produce, and on the other hand, we also want to reduce the carbon emission. So it's a big challenge, and possibly we have to convert this challenge into opportunity. And I can tell you that Ministry of Steel, and also, for example, not only in steel making, I can tell you that, we are also working with MRI on the rare earth, minerals also, and IIT Bombay has been recognized as one of the Center of Excellence. So MRI is partnering with us. So in those also, again, these are all connected with the greening of the, energy sector, many other sector where rare earths are also going to play an important role. So hence, it is very important that academia and the industry and the organization like MRI, we all work together. And of course, on the other hand, the steel industry also employs more than 2 million people directly or indirectly, especially the small and medium scale, they do employ, especially I have visited, for example, Jalna many times, and I know how the scrap is getting segregated by, so many people together, and that's the way they achieve the composition, etc. And this is the, again, how we want to bring down the CO2 emission. So, beyond the 2030, we have our plan is to really go aggressively, and by 2070 or so, we want to reach the zero emission. This is what at least our ambition as far as Ministry of Steel, government plan is concerned. So we all have to work together this plan. But I can tell you there are challenges, and we have to see how we can meet those challenges. Let me tell you, when it comes to green, of course, two things. One is we are talking about hydrogen being used, and the other thing is, even if we want to produce hydrogen, it is energy which is important. So at the end, greening depends on greening the energy. That means energy sector is going to play a very important role. We all know that. And that is going to actually a big challenge for us. Okay? So if you look at the challenges, that's what I am trying to put. Energy is going to be the most important challenge, followed by processes and how we can innovate and manpower. So I just want to briefly go through them. So if you look at the renewable energy component now, I have taken it from the Niti Ayog, you can see at the bottom figure. Still our renewable energy component is much less compared to, the coal or oil, etc. And we also know that renewable energy, when it comes to grid stability, there are challenges. And also the critical minerals needed to sustain renewable energy is quite huge. And that challenges is also very, we need to make sure that those challenges are also dealt with properly. Then only we will be able to achieve those things. And I also believe that we have good nuclear, in terms of raw material, we have good raw material in terms of for nuclear power. But I think we have to develop those also. Then only I think we will be able to meet our energy challenges or energy security, then only all the sectors can become green, I believe so. And we all know about it. We have two sectors, primarily the primary sector and the secondary sector. And we have a unique, secondary sector with a lot of them going through the induction furnace and rotary kilns. So if you look at process challenges, especially I have concentrated on, the smaller plants here, not the large integrated one. So they do result in large carbon footprint, and there is a good scope for increasing the efficiency, and we should work towards it. So we are actually, for example, instead of coal, we can inject, maybe some gases, it is possible. And I also want to tell you there are some technologies which are coming in. For example, you can use a blower I should say a turbo machine, which can actually produce hot gas at around 700 degrees Celsius. Already such technologies are being talked about. For example, Siemens Energy is one such group. I know there are also others. So if such technology comes out and they talk about 95% efficiency of conversion, that means electrical energy to heat energy, then probably, if we can put it in a rotary kiln with the primary air, that can reduce the carbon emission. So some of these things can be explored. We need to explore those things. And again, we know about operating DRI furnaces with acidic lining is a challenge because, that erodes the furnace lining. And again, induction furnace are difficulty using high carbon DRI because we cannot blow oxygen there. That is the other challenge. And the other thing is steel cleanliness, because induction furnace are outside India, and within India also I have seen there are some concerns about induction furnace cleanliness of the steel. So how to address these things need to be looked at. And of course, when it comes to recycling, the segregation of scrap is something which we need to look at. Of course, we also looking at the Indian economy, ours is a labor intensive, so how to strike a balance is something we need to think about. Tramp element control is a big problem, and that is going to come as in more and more recycling is going to happen. Copper, tin are the major culprits as far as tramp elements are concerned. And again, as I told you, the operating with more proportion of DRI, and because of acidic lining, phosphorus control, and steel cleanness. Again, these are challenges as far as the recycling steel is concerned. And as far as using electrical energy is concerned, of course, EAF has high capacity and oxygen blowing is possible. That's the advantage we have. But induction furnace, of course, Dr. Swaran mentioned the carbon emission is much less compared to electrical arc furnace. So, but the capacities are low. So again, we need to look at those aspects. And there are also possible to use induction and resistance heating in place of wherever we are using fossil fuel. Some of these things are already happening. I know that, induction heating is being used for billets, etc., before it goes for rolling. And as I was telling you, there are turbo machines available which can heat the gas directly. So wherever you need to hot air, we can probably look at those. These are some of the possibilities which I am talking about. And we are the second largest producer, but when it comes to innovation, we are still lagging behind. And we need to also innovate, at least coming from an academic institution, that's what I believe. And let me tell you that, academic institution is only a small part of this innovation ecosystem. The idea at the lab scale is what academic institution can provide, but that idea needs to be, so just a research expertise cannot lead into something which is at the industrial scale. So we need engineering, design and fabrication expertise. It is there in the country, I should say that. For example, when I look at some of the companies who are serving, for example, the smaller scale industries, there are engineering and design, expertise is available. These are scattered. We need to come together and we should innovate. And for that, we need to have pilot plants. Again, Ministry of Steel is promoting those things, but these pilot plants have to be done through engineering and design within the country, then only it will happen innovation. Just I want to make also a statement regarding Jugaad. Jugaad is something a good thing. We are proud of those things. Jugaad as a starting point is an excellent thing because that is the idea. But to make the Jugaad to a proper engineering solution, you need systematic studies. I think we have not done that enough, and that is why you see, for example, you may get 70% with a Jugaad, but the 30% somebody out abroad getting it, if we have to reach that level, the Jugaad is a starting point. We need to do more than that. Okay? And again, manpower, we need to think about it. Paranjit Singh will keep on talking about, skilling the manpower. You just look at South Korea versus India, you will see the difference, how the manpower, how different they are as far as India is concerned. If we have to innovate, if we want to green the steel sector, we need people who are more skilled. That only can, we need, SOPs which are planned, and we have to be disciplined, then only we will be able to produce quality steel and green steel. So these are my initial thoughts. With this, let me thank you once again for giving this opportunity. Yeah. Okay. Yeah. So now we will have a presentation from our panelist. Let me just give me a second. And I would request all the presenters to finish the presentation in 10 minutes. I don't know how much time I took myself. I didn't look at the time. On behalf of Mr. Ashwini Bhatia, I think Aishwarya, she will be presenting on low carbon emission steel steel for net zero buildings. Yeah, please.
Good morning, everyone. First of all, I'd like to thank MRAI for this opportunity and for organizing such a meaningful event. Before we talk about industry and sustainability, let's take a moment to face the reality of the climate crisis. We are the first generation to feel climate change and the last that can do something about it. 2024 was the hottest year ever recorded. Arctic ice is melting fast and sea levels are rising at record pace. The world aims to limit warming to 1.5 degrees Celsius, but we're still far off. India contributes about 7% of global CO2 emissions, yet we have pledged to cut emission intensity by 45% by 2030 and reach net zero by 2070. The message is clear. Fighting climate change starts with transforming the industries that fuel it. The construction sector alone accounts for nearly 40% of global CO2 emissions. When we talk about building emissions, there are two types: embodied carbon and operational carbon. Embodied emissions are the total greenhouse gas emissions generated from raw material extraction, manufacturing, and transportation of construction materials even before the building is occupied. And operational carbon emissions, on the other hand, comes from the daily running of the building, energy used for heating, cooling, lighting, and appliances. Together, they make up the building's life cycle carbon footprint. So, if we're serious about climate goals, we can't just make buildings more energy efficient, we have to also tackle the carbon footprint embedded in the material themselves. And that's where the conversation starts to connect with our industry. Now, let's take a moment to talk about why embodied carbon is so important to consider even before the design of a building begins. Embodied carbon is the total carbon footprint locked into a building before anyone moves in. In India's building sector today, operational carbon makes up about 85% of total life cycle emissions, while embodied carbon accounts for around 15%. By 2050, operational carbon will fall sharply due to energy efficiency and renewable power. But even as materials like steel decarbonize, steel will remain one of the largest single contributors to embodied carbon in most new buildings. If you want net zero buildings, we must tackle embodied carbon from day one, because once it's emitted, you can't take it back. Let's take a closer look at where most emissions actually occur in a building's life. When we look at a building's life cycle embodied emissions, around 72% of all emissions happen before the building is even operational. That is, during the product stage and the construction stage. Looking closer at construction material emissions, steel is the largest contributor at 45%. This means steel alone is responsible for roughly 40% of all project phase emissions. And that is why steel is the single most powerful lever for reducing embodied carbon in buildings. A change here can transform the carbon profile of the entire project. And that's exactly what we're here to discuss today: how industries like ours can be part of the solution, not the problem. The vision of ARS is to become the most trusted and reliable brand committed to sustainability, carbon neutrality, and enduring stakeholders' delight. ARS Steels, founded in 1992, is a leading integrated steel manufacturer with a production facility located in Chennai, Tamil Nadu. Our experience spans over 46 years in steel industry, particularly in procurement of premium recycled steel, including 33 years in billet manufacturing and nearly 22 years in producing steel rebars. Our current installed capacity is 3 lakh tons for mild steel billets and 2,76,000 tons for TMT steel rebars. Our future plan is to increase TMT rebar production to 0.5 million tons per annum by Jan 2027. We aim to produce 1 million ton per annum of green steel rebars by 2030. We are pioneers in production of 100% D-quality steel TMT rebars and have been consistently producing from the past 6 years. D stands for ductility, where sulfur is less than 0.04% and phosphorus less than 0.04%. We also produce 550D CRS, where CRS stands for corrosion resistant steel. CRS is produced by adding and maintaining copper, chrome, nickel and moly, ensuring the longevity and durability of the structures, thereby extending the lifespan of the building. ARS-CRS steel bars are perfect for challenging environments such as construction areas with poor groundwater quality, where the TDS levels exceeding 400 ppm, making them ideal choice for high-rise and critical infrastructure. Every batch of our steel rebars are tested and certified in real time at the production point by SGS, the world's #1 testing, inspection and certification agency. We are proud to say that our materials not only meet domestic standards but also surpass export quality parameters. We offer a unique testing facility at the customer's site free of cost through our Tech Express van, equipped with a German-made spectrometer capable of analyzing 32 elements. This ensures the authenticity of quality is verified accurately and instantly. We use over 98% premium quality recycled steel, such as CRC, CRC bundles and HMS, which inherently have lower embedded carbon and deliver clean, consistent quality. Our sponge iron consumption is less than 2%. By using our 98% recycled steel, we demonstrate a powerful commitment to recycling and waste reduction. To maximize efficiency, we have invested in advanced steel processing equipment, enabling us to achieve an impressive yield of over 95% and achieving best-in-class electricity consumption of around 725 kilowatt units per ton, including billets and TMT bars. To give you a breakup, 650 kilowatt hour per ton from billets and TMT bars and 75 kilowatt hour per ton on the auxiliary load. We've committed ourselves for procuring RE by entering into 25 years long-term PPA, helping us reduce Scope 2 emissions and reduce reliance on fossil fuel-based grids. We've made equity investments in captive renewable power projects of more than 70 megawatt wind and solar. At present, we are consuming around 28% of our total electricity consumption from captive renewable power projects. Our latest EPD confirms CO2 emissions at 592 kilo per ton of steel. This emission intensity of 592 kilo CO2 per ton of steel is over 4 times lower than the Indian average, more than 3 times lower than the global average of 1850 kilo CO2, and about 5 times lower than emissions from the conventional blast furnace route. One of the biggest myths in our industry is that secondary steel is inferior. The reality is very different. Steel quality depends on quality of input raw material, not on whether it's called primary or secondary. According to the Ministry of Steel, there's no difference between primary and secondary steel. The only factor that matters is whether the steel meets BIS standards. At ARS, we use premium quality recycled steel such as CRC, Newton plate, punchings, etc. As you can see in the analysis, the chemical composition of our recycled input is significantly lower than the prescribed IS 1786 limits for carbon, phos, and sulfur. For example, for CRC sheet, carbon is only 22% of the IS limit, phosphorus just 16%, sulfur only 25%. So the key message is simple. Premium input recycled steel equal to premium output steel. There's a lot of substandard or fake quality steel entering the market, often produced through sponge iron/DRI. This material inherently contains high sulfur and phosphorus, which weakens the steel and compromises the long-term durability. Now let's look at the output, our ARS-CRS 550D TMT bars. Here we are comparing both chemical properties and physical properties with the IS 1786 standards, and they consistently within the prescribed IS limits. The message is clear that when recycled input is premium, the output will also be premium. So this is our ARS formula for green steel. So recycled steel in combination with renewable and with no fossil fuel usage, we create green steel. India has introduced the green steel taxonomy, where steel manufacturing plants are rated by CO2 emissions per ton of finished steel. 5-star for less than 1.6 tons, 4-star between 1.6 and 2, and 3-star between 2 and 2.2 tons of CO2 per ton of steel. ARS Steel is number 1 in the country to receive the Green Steel certificate from the Ministry of Steel and number 1 producer of low CO2 TMT bars with 5-star rating. ARS Steels is around 2.5 times better than the best with CO2 emission intensity of 0.6432 tons per ton of finished steel and has greenness of 70.8%. At ARS Steels, our commitment to sustainability is reflected not only in our operations but also in the certifications we hold. With EPD by default, ARS Steel is fully compliant to be used for LEED certified projects, including LEED version 5 embodied carbon. ARS Steel is the first and only steel company to be included in the Griha product catalog. Our products are Green Pro certified. We are in the process of publishing our first ESG, Environmental Social Governance, and BRSR report by mid-November. Given the Indian steel industry as one of the highest carbon intensities in the world, at ARS Steels we are on a very different path. Today our carbon intensity is just 592 kilograms of CO2 per ton. That's around 77% lower than the Indian average. And we're not stopping here. Our future target is 250 kilograms of CO2 per ton, which would mean a 90% reduction compared to the national average. And how are we achieving this? We are achieving this by sourcing over 98% premium grade recycled scrap, using more than 80% renewable energy, running highly efficient electric induction furnaces, and driving continuous process improvement. In short, premium recycled steel with renewable energy isn't just the cleanest way to make steel, it's the smartest way. So this is our roadmap, where in 2023 we published our EPD with a baseline of 850 kilo. In 2024, the renewable energy increased to 28%. 2026, we are on track to reach 80% renewable energy. 2028, we aim to become net zero. And in comparison to the Ministry of Steel target, we are already way ahead. So we've implemented a digital CO2 emissions tracking tool that tracks and reports CO2 emissions on a real-time basis using the World Steel Association and GHG protocol calculations. Here we get CO2 emissions at the heat customer order level, and this is integrated directly with our internal data systems, ensuring carbon footprint report is 100% automated, accurate, verifiable, and audit ready. We believe the definition of green steel is not sustainability, but it is low emissions with high quality and ultimate transparency. At ARS Steel, transparency is not just a principle, it's a non-negotiable commitment that defines how we operate. We provide ultimate transparency on quality, sustainability, and customer service. We don't just talk about quality at an aggregated level, but at a heat and customer order level. For each heat, we track the ingoing recycled steel properties and test the molded steel quality via our NABL certified lab. Post that, billets and TMT bars for each customer order are tested on-site and real-time through SGS. ARS has also invested into 12 mobile testing vans equipped with German-made spectroscopy. All these tests and reports are available on our cloud-based digital platform. So ARS Steels is the only company in India that assures TMT rebar samples taken from anywhere in the market will consistently meet and pass stringent quality tests. Our quality standards are so robust that customers can confidently export our TMT bars, assured that they will meet international standards. These are some of the different types of recycled steel scrap that's purchased by ARS. And this is our local and import scrap procurement percentage with our sponge iron less than 2%. At ARS, we believe sustainability starts at the very step, and our focus has been on strengthening local scrap procurement, which not only supports India's vision of self-reliance, but also ensures long-term sustainability and supply stability. We've invested in scrap processing equipment, including baler, shear, and shredder machines, to make sure every ton of scrap we procure is processed clean and ready for direct charging into the furnace. This brings multiple benefits: superior quality steel, higher material efficiency, and lower embodied carbon. So given that now we have discussed how ARS is improving sustainability through scrap procurement, let's look at how government policy support can further drive the adoption of green steel. So the electricity used in steel making contributes heavily to scope 2 emissions. By switching from grid or thermal power to renewable resources like solar and wind, these emissions can be reduced by 60 to 80%. So there are few areas where supportive policies can make a real impact. The first one is about enabling high renewable power usage for green steel. To make this effective, we suggest allowing renewable electricity generated during the day to offset power consumption across all 24 hours, covering morning, evening, and night melting slots. And we request that existing provisions allowing solar energy to offset peak and nighttime usage remain unchanged for the full 20 to 25-year operational life of the renewable plants. Policy stability is absolutely critical, and we request that any changes in energy banking or settlement rules be applied prospectively, not retrospectively. The steel sector also needs support for battery energy storage systems to make round-the-clock green power viable. This can be enabled through waiver of transmission and demand charges, accelerated depreciation benefits for battery assets. While compliance is important, we also need strong incentives to accelerate low-carbon steel adoption in the private sector, and we request incentives for developers who demonstrate embodied carbon. We also request to go beyond the 5-star benchmark, where a 6-star and a 7-star rating can be created. We also want to add that under our suggested framework, we suggest aligning the green public procurement policy to reward performance, maintaining 20% allocation for 3-star producers, but increasing to 15% for 4-star, 10% for 5-star, 5% for low-carbon steel below 1 ton CO2, and 2% for global green steel standard. While I close, I would like to add that we have successfully we've done our first green steel sale with Epic Group and with their manufacturing facility in Bhubaneswar. And we have also supplied 3-in-1 DCG, which is ductility, corrosion resistance, and green steel to GMR, the Delhi International Airport. Thank you.
Thank you. Thank you, Ashwini Subaraman. Yeah, Mr. Ashwini Bhatia would like to make a remark. Okay. Then I would like to now invite Mr. Rohit Agarwal, Project Head Steel Recycling JST.
Now good afternoon. So very good afternoon to my friends and colleagues from the industry. I am Rohit Agrawal. I am heading the recycling projects and also the scrap procurement for JSW Steel. A lot has already been said, so I'll really very briefly take you through we as a country, where we are poised around carbon emissions and why we need to have an inclusive approach, whether we as manufacturers, the government agencies as the policy makers, and more importantly, the policy implementers, our customers who actually need to market green steel, that is where the money actually comes from, the various intermittent agencies who are involved, which also includes a lot of scrap processors who are there today, and the, let's say the way the scrap moves from, one place to another. There are a lot of agencies involved today, and this needs to be an inclusive approach if decarbonization really needs to run in the country. Just to give you a comparison, I think we're all talking about carbon neutrality, but first we need to really draw parallels with where the world is today. Since about 80% of the steel that we make today is through the iron ore route, our carbon emissions are approximately 33% higher than the global average. Of course, I mean, we've heard about ARS, and there are others also who have their carbon emissions much lower than what the country's average today is. But looking at the scale at which we produce 150 million ton today and going up to about 200 and 250 million ton in another 4 or 5 years' time, I think the first target which we together need to take is to draw parallels with the world, come to where the global average is, and then look at strategies of how we need to further take it ahead and move towards carbon neutrality. I've really tried to sum up, as to why scrap is important. We've talked about, different initiatives, as people have asked, why scrap, or why, scrap is the first answer. Scrap, of course, has the CO2 reduction potential, as we all know. We've seen numbers which are, much lesser than 0.5, 0.3 ton of CO2 per ton of crude steels, of course, CO2 reduction potential. Economic viability, of course, especially with respect to the CAPEX. OPEX obviously comes next, but even CAPEX in the other decarbonization initiatives are much higher, compared to scrap. And technological maturity, as a country, we are already sufficiently mature into scrap. We as integrated steel manufacturers are not as much, but yes, of course, we are also learning and trying to move with the tide. India's story here, again, we've tried to sum it. Today we are at about 30 million ton of, scrap production, 25% dependence on import. The story is pretty much likely to be similar when we look at FY30 levels. The major reasons for them, I'm just adding to what people have already said. It's basically the policy implementation for the last 6 years, at least since I remember 2019, when the steel recycling policy was drafted by some of our team members itself. From then on till now, there have been a lot of changes. There's been focus on trying and seeing more of policy coming into the decarbonization side, but then the implementation on the ground is not really there. That's one of the reasons that today we are at 30 million ton, and we still look at only 40 million ton going at 2030, while the requirement is going up to about 55, 60 million ton. The second, of course, is decentralized supply chain. There's a lot of local scrap available, but then how much of that and what is the most efficient way it is routed to, let's say the steel furnaces. Of course, our customer scrap, and we again saw it in ARS's presentation, the customer scrap can come to India, that come to the furnaces, which is basically the prompt scrap that is generated at, most of the automakers or the fabrication units. But largely the obsolete scrap, if India is, growing in terms of steel production, there'll also be a lot of steel consumption, and therefore more and more of obsolete scrap that needs to come into the channel. So, that decentralization needs to be converted to centralization. And lastly, of course, while there are policies around EPR now for auto, there needs to be many more policies across different industries, because the lead time for scrap to actually come back from consumption centers to the let's say the furnaces is really high. Let's say, for example, auto is 15 years, it's still not reachable here. I mean, if you compare it to the other countries, it is much lesser than that. And the other industries yet to have an EPR. So, from the policy implementation side, the supply concerns, we need to really pull up our socks and take up and reach the levels where we want to reach at about 55, 60 million ton by 2030. The domestic policy interventions, we talked about steel recycling policy 2019. First time, that we talked about circular economy and why recycling zones are important. Today, we as a company, JSW Steel, if I was to put it, we are making about 35 million ton of capacity we have in India. We are trying to grow to about 50 million ton by 2030, and the plan is even beyond that. We're also already talking about 75 million ton beyond 2030. Recycling is something that we've started to do now in terms of scrap. It is a privilege for me to announce that, we've been part of setting up this first recycling unit of ours that will be in Khopoli, which is to cater to our Dolvi unit. That will be about 0.5 million ton of capacity. The second recycling unit we'll be having in Chennai. Our JMD and CEO just announced that about 10 days back. So that will be about 0.5 million ton again. And there's a structural 1 million ton of structural steel unit that we are putting up again in South, which will largely be based out of scrap. So that's some, let's say some ground that we've tried to make on recycling. As far as our internal scrap usage is concerned, people have said various numbers. The solid charge, of course, is about 15 to 18%, but then the scrap charge, and especially the scrap that comes from outside, is not very high. Today, our overall scrap charge is about 5%. If I just look at clean scrap, we intend to take that to about 10% with the help of these policies that have been mentioned on this page. Vehicle scrappage policy, of course, I'll talk more about the potential of this policy in the next pages. GST rationalization, there has been some ground. I mean, we should appreciate the government to at least introduce 2% TDS. Of course, I know it's not enough. Most of our secondary steel friends are sitting here. 2% is not enough in terms of TDS. We've been advocating for reverse charge mechanism and also advocating for it to be changed to 5%. Let's see how soon we reach there. Green steel taxonomy, people have talked about it. EPR policy. I saw some of the auto customers of ours, Toyota, Kirloskar, etc., have talked on EPR policy. I'll speak about the potential in the respective pages. ELV recycling, if we take government data itself, about 22.5 million ELVs, which includes the two-wheelers, are available today for recycling. All of that actually got recycled. We would not need to depend on import at all. It would generate about 6 to 7 million ton of scrap. But even through the informal route and the formal route combined, today we're doing less than 1 million ton of scrap from the ELV scrappage actually. So that's the potential. That's about how important it is to actually implement, which is already a policy today. And it's not that there aren't people who are aware of the subject. There are different regions or different major clusters all across the country which have got these ELV clusters. NCR does about 25-30%. West is not far off with Mumbai and Pune region, Chennai region. So there are clusters where ELV recycling actually happens. It's more about formalization and getting them organized so that this can come faster and more efficiently into the steel making. I've tried to, mathematically put down as to what is the dilemma and why does actual scrappage not happen? Why does it go to people as in resale of vehicles, even if they are 15 years or older? About 25% is the actual difference if we look at the, the potential that scrapping it and the difference between the potential that scrapping it and reselling would have in terms of PV. A typical 10 lakh PV would sell at about 1 lakh at the end of its life cycle, just an assumption. About 25% lower than what the value that you would get for scrapping it. And when you scrap it, you take it through different agencies. Similarly on a CV. So there is a proposal that had come, from North itself, that if you increase the road tax concession by or 250% at both PV and CV level, we'll be able to bridge this gap. I think this is important. First, because there isn't much awareness, so that awareness will be created. And then, once people start getting into it and start getting into, this practice of actually scrapping their vehicles, then we can look at, how we improve the policy further. But I think the margin is not too much. The government can really think about it. From the EPR policy that has recently come up, which says that, for the 3 years that are listed here, from FY 25-26 to FY 27-28, the automakers need to at least recycle 8% of the steel that went into, car making 20 years ago. So if all of that is actually recycled from this, policy itself, there'll be about one charge mechanism in full, or maybe a 5% on GST can come. We've spoken about this. Yes. Why is a company like JSW Steel going into more of external scrap purchase is answered through what responsible steel as a definition has for scrap. Scrap is anything that is beyond crude steel. It would not mean the scrap that is processed out of the slag that we generate. The external scrap is only, let's say, the scrap that you generate from the rolling mills, which, if you increase your efficiency, actually comes down. But it is the external, the obsolete scrap that you would need to increase if you want to reach the, if you want to really make a mark in terms of CO2 emission reduction from a responsible steel standpoint. We're putting up shredders, like I told you, we're putting up shredders, shears and balers. We're all aware how these look like and the scrap that is mentioned here. But the typical investment to put up a 0.5 million ton recycling unit is about 200 crores. We at JSW Steel are, taking this leap, and we hope that the industry together along with the government helps us around with it. And more people are encouraged towards doing it. Nobody has put up a shredder as large as the one that we are putting up at both Khopoli and Chennai. We want more and more of this to come, and more of this to come through the indigenization route, rather than, we having to import. So the comparison between US and India, US has about 300 shredders, India's just got some number that can be counted on fingers, 10 or 15 shredders. And while we are trying to catch up, but the road is really tough and long, and we all know the reasons why, and we all know what role we need to play in catching. Challenges, we've spoken about the challenges. So as a company, from where we were at 2020 and to what we'll do in 2030, we were at about 2.5 ton of CO2 per ton of crude steel. We intend to take it down to about 1.95. That's what we've committed for 2030 levels. And scrap, for every 1% increase in scrap charge that we do, we save about 0.02 ton of CO2 per ton of crude steel. So about 0.2% would be the contribution of scrap in the overall decarbonization initiatives that we have. As a company, or maybe as a responsible citizen of the country, we would encourage all of us together. So scrap is one answer, of course, it's the easiest and the fastest answer. But then let's look at whatever best possible efficiency drives that we can take within the organization, not just from the purpose of saving for ourselves in terms of rupees per ton, but also from CO2 per ton levels. Thank you.
Thank you, Mr. Rohit Agarwal. Now I would like to request Mrs. Aradhi Bosling.
Good afternoon, everyone. So stalwarts from the steel industry have already talked more about the steel manufacturing process and decarbonization and all. So I would like to add insight on a new topic, that is life cycle assessment and environmental product declaration for the steel industry. And now I am going to cover the global steel impact, India Steel Leadership Life Cycle Assessment EPD framework. What is LCA? What are the benefits of LCA? What is EPD? What is the process to get EPD published? And what are the benefits? Yeah, Here we can see the global steel industry impact. As you know, 8% global emissions are from the steel industry, and totally we are like 1.9 billion tons global steel production is there, which is contributing 8% of global pollution. So this is the India Steel Leadership and Decarbonization. So we are around like 22nd largest producer of steel. That's why there is need for decarbonization. So our target is net zero by 2070. That's why there is a need for LC and EPD. So here we can see the steel making routes in India. This is data of 23-24. We can see the routes of steel manufacturing and the share of production and the emission intensity. So it is around like for a blast furnace, it is 2.2 to 2.3. For DRI EF, it is around 1.4 to 3.0, and for scrap, it is around 0.6. So the overall percentage, like for blast, it is 43%, DRI, it is 30%, and for scrap, secondary steel, it is 27%. So what is LCA? Basically, all of you may be aware about LCA. So LCA is nothing but to know your product's environmental impact from its raw material extraction stage to its end of disposal. So for, like there are different system boundaries, that is cradle to gate, gate to gate, and cradle to grave. So different industries, there are different system boundaries chosen. For if it is a chemical industry, then we can have a like cradle to gate system boundary because the chemical is being used. after it is sold out to the customer. But for steel industry, as it is being recycled, then we can have a cradle to grave system boundary, that is from raw material extraction to its end of disposal. So for different industries, like if we take an electronic transformer, that is an electronic product, then in that case, like 90% emissions are because of use phase, and around 5% is because of the raw material extraction and the transportation part. But if you take an example of steel industry, like raw material extraction, manufacturing, and your transportation contributes 95%, because major part like that is coal, and your other part is coming into A1, N2, A3. Yeah, so here we can see, basically this is a system boundary for environmental product declaration. Here we can see raw material supply, transport and manufacturing, that is a mandatory part to have an EPD, that is A1, A2, A3, which is almost 90% of total emission. And then A4, A5. So B1, that is use stage, is not basically applicable for the steel industry. So that is not declared. That means we can exclude those parts from the EPD. The next part is end of life stage and resource recovery. So end of life, we can say basically the deconstruction stage, then transport to the waste processing facility, whatever electricity used for the waste processing facility is considered into this stage. And the next part is reuse and recovery. So because of steel in recycling part, we are getting some benefits or credits. That's why we will be considering the cradle to grave system boundary for steel industry. So next is, what is EPD? So it is verified and transparent document. We can say layman's language, it is a summarized form of EPD basically. So anyone from the world can access your product's environmental performance from the EPD portal. So there are like 3-4 EPD program operators in the world. One is EPD International, one is EPD Hub, and EPD Norway. Now it is converted into EPD Global. So most of like India, EPD International is preferred. Here we can say. So EPD International, almost around, I would say 10,000 EPDs are published globally. Out of that, we are having around only 250 to 300 EPDs in India. And out of that, 25 to 30, 40 EPDs are published for basically steel industry. So this is a data which I have just recovered from those EPD published, we can say. So ARS group is also there, it is around 0.6, as just Aishwarya explained here. Then Jindal SAW Limited is there, 1.82. So we can see here the difference. So basically this is upon the, depends upon the route of the manufacturing process. But we can say we are on a better side, like 0.3 I can see here is the best result over here. Then 0.6 is there, then 1.82, there are so many results. So almost 40 EPDs are published in India under the EPD International platform. So the overall 1,300 EPDs from 10,000 globally published for steel and metal section. And out of that, we can say 40 are in India. Around 250 to 300 EPDs are published. As a consultant, I can proudly say I published 50 EPDs from that nationally, internationally, for steel industries, construction industries, chemical, for electronic transformers. What is the process of to get the EPD basically? So as a consultant or as a manufacturer, you have to give us the data, how your steel is being manufactured, what are the raw materials, what is the manufacturing process, how it is transported to your in-gate. So this kind of data basically we need to prepare any LC and EPD report. Then after preparation of LC and EPD report, this has to be verified by the third party verifier. So it is not like that I am in a favor of any company and I am going to give the result like it is a 0.2 tons of CO2. So it is not allowed. So it should be verified by the third party verifier. So many program operators like EPD Hub, EPD Norway, they have appointed the EPD verifiers. So we have to verify our EPD from those verifiers, and ultimately the EPD will be published. So like I would request of all the steel industries can go for the LC and EPD, because there is also a cost difference in different program operators. We can go with the EPD Global, that is EPD Norway, we can go with the EPD Hub, we can go with the EPD International, so as there are so many benefits are divided into these different program operators. And the overall validity of this EPD is around 5 years, so it is always good. Yeah, so what are the benefits? You can see here strategic advantages are always there. Your global market access is there. Also, we will get a certification support, that is LEED, BREEAM credits are there. Also, you will get benefits into EcoVadis. In EcoVadis also, they will ask whether your LCA and EPD is published or not. In your ESG reporting, in your BRSR also, so for top listed 1,000 companies, BRS are mandatory, and they also ask about this LCA and EPD. Then process optimization is also there, stakeholder trust and cost reduction. So these are more benefits about the EPD. Yeah. So what we can do for you for steel industry, basically we do have a like consultancy for all of these things along with a tailored software, we can say. So we not only provide you the LCA, the CBAM and the GHG quantification, along with this we do have a EPD like software also. You just have to put your data and your EPD will be immediately ready. And after that we will be supporting you for your EPD verification. Along with this, we will also help you in ESG reporting, your BRSR, your EcoVadis, CDP. So this is a customized and tailored software, that is GreenX Nexus 2.0. So it is soon available in the market. If you want a demo kind of things, we will definitely provide you the demo of this software. Yeah, so this is about LC and EPD. Thank you.
Yeah. Thank you, Ms. Arati Bhosle. Now I will invite Ms. Amrita Kandekar.
A very good afternoon to everybody present here. Firstly, I would like to thank MRAI for the opportunity to make this presentation. So my topic for today is global green steel development costs and challenges. To start off a little bit about Argus Media, we are a global commodity market intelligence firm and a price reporting agency. We are based out of 29 offices across the world, and we publish reliable news, price assessments, and benchmarks on a number of different markets, including metals, hydrogen, fertilizers, and energy. So this is how my presentation will be structured. I will talk about the global steel prices and market trends. I will follow that up with CBAM and its implications for the global green steel push. I will also talk about different ways to produce green steel and the kind of costs that are associated with them. And finally, I will give an overview on the scrap market, given that scrap is such an important tool for global decarbonization. So global steel prices across most regions have been under pressure for the last couple of years. If you see, they are trending well below their levels in 2021 and 2022. And one of the key reasons is persistent oversupply in the market because of expanded capacities and weak domestic demand in many regions. Chinese steel exports have continued at a robust clip, despite several trade measures and anti-dumping investigations over 2024 and 2025. And now the industry's focus is basically on how China cuts down on its overcapacity and stabilizes its steel sector, because that will have a far-reaching impact on many different markets. In the US, the story has been a little different from what has been happening in the rest of the world so far in 2025. And that is, of course, because blanket steel import tariffs were imposed in March and then doubled in June. And that has given a boost to the US ferrous sector, prices, and production. In India, provisional safeguard measures were put in place in April, and imports have trended lower in 2025 as a result. Despite that, there has been no pickup in domestic hot rolled coil prices, and there's a number of reasons for that. There were extended monsoons this season, and mostly the reason is that Indian domestic capacities have risen, which means local supply has really increased. So this has been the story so far in 2025. But in 2026, things are going to change. One of the key factors to watch out for is quota changes in Europe. So the European Commission in October has proposed sweeping cuts to import quotas across several flat-rolled categories, including HRC. And it has also proposed raising the out-of-quota tariff rate to 50% from 25%, echoing what has been happening in the US so far. But this measure is likely to be imposed sometime later in 2026. The estimate is around July, when the current safeguard framework expires. Much earlier on in 2026, there's going to be another very important development, which is that CBAM is going to enter its definitive phase from the 1st of January. And this basically means now there will be a carbon cost associated with importing steel into Europe. So under Europe's current emissions trading system, domestic steel makers get a certain portion of their allowances for free to cover their emissions. Similarly, under CBAM, initially there will be a free allowance factor, which means a certain percentage of the benchmark value that will be given by the European Commission will not be immediately subject to emissions. But this free allowance factor will phase out over the course of the next several years till 2034, which means more and more emissions in an imported product will be subject to carbon taxes. So the European Commission has not yet come out with its benchmark values, but I've just considered 1.4 tons as the benchmark and 2.3 tons as the embedded emissions to give you the picture on how it's going to look like. But regardless, this really underscores the need for global steel makers to shift to greener pathways. So how can that be done? There's multiple ways in which steel makers can decarbonize. Yeah, there's multiple ways in which steelmakers can decarbonize, but there's costs associated with each method and a number of challenges along the way. For example, in Europe, which is really going big on decarbonization, a number of green steel expansion projects have been delayed so far in 2025. And there's a number of reasons why that has happened. One is, of course, that renewable hydrogen remains commercially unviable. Second is that Europe's steel industry is battling a lot of challenges at the moment, including high energy costs, weak steel demand, and automotive sector that is struggling with competition from Chinese EV makers and the tariff situation. And also there's imports coming in and taking away a portion of domestic steelmakers' market share. So given that there's this whole storm of conditions, the business case to make really capital-heavy investments in green steel remains weak at the moment. So as I said earlier, there is a cost to going green. And Argus has a number of price assessments that showcase the operating costs associated with different methods of steel production in Northwest Europe. So the line at the very bottom here showcases the costs associated with the traditional BF-BOF way of production. And the line at the very top showcases the costs associated with making zero-emission steel using the DRI-EAF process in Europe. And the difference between these two is roughly around $460 per ton at the moment, which is not a small amount at any rate. Whereas if you see the line just above the BF-BOF line, indicates the costs associated with making steel in an electric arc furnace using scrap and renewables. And in terms of costs, this comes the closest to the BF-BOF line, and the differential is just about $1 to $5. So this just indicates that going forward, at least in the near term, scrap is the most cost-effective way to produce green steel, at least until newer technologies like hydrogen become more commercially viable. So just a little update on the scrap prices. Global scrap pricing has also been constrained by the weakness in finished steel markets. China has really stepped up its exports of semi-finished steel products like billets, and because most of its finished products are under trade measures at the moment. So this has also spoiled the fundamentals for scrap demand in several countries. For example, in Turkey, steel producers quite often rely on this lower-cost imported billet over scrap because they want to protect their margins in a very challenging environment. There's a couple of green shoots here and there. For example, in Vietnam, it's turning out to be a bright spot for scrap demand at the moment because there's some blast furnace capacity coming online and local steel consumption is increasing. On the supply side, there is a little bit of tightness because since the US tariffs were imposed and US domestic steel consumption rose, more scrap volumes have been moved inland for domestic consumption, leaving lesser volumes for exports. But despite these factors, there's a cap on scrap pricing at the moment because of overall the downturn in the finished steel market. So this chart here just shows you how US steel mill utilization has increased since the tariffs. So it reached nearly 80% in June after the tariffs were doubled. So now we can see that there is a lot of electric arc furnace capacity that will be added in many regions over the next several years, particularly in US and Europe. So, and other countries are also making an active effort to decarbonize. They're setting net zero goals. So this basically raises the possibility that major scrap suppliers such as Europe will try to rein in their scrap exports or put some kind of restrictions on their scrap exports to make sure that they have enough scrap supplies to meet local needs. And so far there has not been a scrap export ban as such, but there has been an ongoing difference of opinion between European steelmakers and recycling associations, where steelmakers are pushing for such export restrictions on scrap, whereas recycling associations are saying Europe has enough scrap supplies to meet local needs, and putting any kind of export restrictions on scrap would harm global decarbonization goals. So what does this mean for countries like India that still depend on imported scrap to meet a portion of their scrap needs? As discussed previously, India's scrap prices have trended lower because of the overall weakness in the finished steel market. Additionally, India's scrap supply chain domestically is very fragmented, very unorganized. This has also pushed several steelmakers towards increasing the percentage of DRI in their charge mix. And DRI is, of course, more easily available. Production is on a rise. But the problem is that 80% of India's DRI capacity is coal-based, which means it's higher in terms of emissions. So yes, while DRI could help India reduce its reliance on imported scrap, it won't help India really reduce its emissions. So I just have a few concluding thoughts here to wrap up the presentation. But the key takeaway is that the world's attention right now is fixated on scrap as the most cost-effective and the most efficient way likely of really reducing emissions. So going forward, there is going to be more competition for scrap, and as I said, some countries might try to rein in those scrap exports. So it's really important for countries like India to become self-sufficient in terms of meeting their scrap needs locally. And that brings me to the end of my presentation. Thank you very much for your time. And this is, okay. Please feel free to reach out to me if you need any more information or have any questions. Thank you.
Thank you, Ms. Amrita Kandekar. Yeah, thank you very much. So I thank all the speakers. So now we'll go to the panel discussion. So let me start with Agarwalji. So the average per capita steel consumption for the world is around 200 or 220 rather, and India is less than half, around 100 now. So this points to the fact that unlike the Western world, we continue to produce a large amount of steel from iron ore, which of course, at present is very carbon intensive. So at the same time, we need to go towards less carbon intensive processes, which includes scrap recycling. So being from a large integrated steel manufacturer, especially you produce so much from iron ore and which is needed for our country, how do you see the Indian steel production evolve in the coming years? Because both scrap and we need both. So what are your views here, please?
Yeah. So firstly, yes, we are at about 108 kg per capita steel consumption against global average of 220. This is estimated to reach to about 160 kg for India against a global average going to about 233. That's by 2031. So of course, we are nearing towards the global average. That's one part of it. The second part, of course, increase in scrap proportion. See, the BF route is there to stay. It will stay. I mean, if we need to scale to where we want to go, the BF route will be there. I mean, it is not correct to say that, this route will immediately diminish. Of course, by 2050s and beyond that, it may diminish, provided, there is enough support from the government and everybody else on CAPEX. But increase in scrap charge, of course, is one part. The second, as I had also said in my presentation, the energy efficiency that we are doing, along with our group company, JSW Energy, the material efficiency that we have, from within what we generate in the plant, and various other initiatives that can be taken on, which may not be very capex or opex heavy. I think that is where all steel companies really need to really concentrate. That's one. The second is, again, I've been advocating, this needs to be an inclusive approach. It's not a primary versus a secondary, or a government has to do something and a steelmaker doesn't have to do anything and just wait for the government to bring in the incentives. It all needs to go together. And whatever journey has been covered, it has actually come because people have gone together. From the policy that was made, like I said, steel recycling policy was not made by the government exclusively. It was actually taking the consent of the various steel companies, including us. So I think that is how we need to approach. Thank you.
Thank you. So now let me ask Bhatia ji. So recycling of steel being greener, many countries are already holding to their scrap, or that's exactly what she was also indicating. Possibly that is expected to impact the scrap availability for India. On the other hand, because of overcapacity and other reasons, we are also concerned about China dumping steel. I mean, this is also many times, at least I do, come across this talk. So how do you see steel production through recycling route is going to evolve in the coming years, or what means how we should promote that? How do you think we should do it? Yeah.
See, I think as per this recycled scrap is concerned, first we have to focus on the quality of the finished product. We are struggling with a gap between scrap and the finished product. So we have to improve the quality first and take the price up. That's the first thing we need. Second is scrap. I don't think there is so much of challenge as per we are concerned, but definitely it's compared to a sponge iron, that is different ball game. This is different ball game. There's no comparison. Like blast furnace. Now, blast furnace, when green hydrogen will come, when it will come, it's a 5 to 10 year at least to get some clarity. So what is today low hanging fruit is a renewable power and the scrap. So with combination of this, I think, and the more focus on local procurement, which you can process your internal, like we are doing around 65% local only, 35% we import it. And that also we are processing in our plant only. So that's the route which I understand. As far as China is concerned, China has its own if and buts, and there's so many your tariff issues going on, protection is going on. It will settle down. Ultimately, not a long-term story. So we have to take care of our industry from the China. There is no second thought. And as per we are concerned, as per India, I think it's really appreciable. The Indian government first, they come up taxonomy. I think taxonomy is very important. We have to take it forward. It's the first step to create a building.
Thank you. Mr. Mayur Shahji, Mono Steel, yeah. So, see, I have visited Jalna several times, so my experience is from there. So at present, especially the recycling industry is very labor intensive. And I believe, of course, India we would like to promote more labor because of our own, ecosystem. So, but at the same time, there are also challenges when the scale goes up, which is expected, sometime soon. And also maintaining the quality. This is the other concern we have when it comes to quality. And especially, we talk about tramp elements, copper and tin. This can become a challenge when it comes to recycling. So, so how do you think shifting from labor-intensive manufacture to more, automation, especially in segregation, sorting of scrap, do you think it will be helpful to the recycling industry, or we should maintain our unique labor-intensive? I mean, how do you go about doing this? Because elsewhere in the Western world, it is all more automated ones, but here we also need to take care of our labor market. So how do you think we can strike a balance? Yeah.
So now coming up basically first with the recycled scrap. So we basically import the scrap from different countries, all UK, Europe, USA. So these countries, they have got the big shredders. Along with that, they've also got the tramp removing system where they remove the copper, chrome, nickel, everything, right? So it is basically the process scrap that's coming up from imports. Now coming up with the domestic scrap, when you have reached with the furnaces on big powers, so you have to come up with the shredders over here, sharing machines, which will improve the efficiency. And coming up with the labors, you have to uplift them. You have to organize skilled labor programs for them in a way because they are your assets. If you try to build them in a proper manner, they would be very beneficial. And coming up with the technology when you are on a large scale, you have to be very dependent on electric machines. Previously, when there were small furnaces, 5 tons, 8-ton furnaces, people used to put the scrap with their hand in the furnaces, right? But now, when we have got 30 tons, 40 tons, 50 tons, 60 tons furnace, induction furnaces, so you have got all the machines, they work for you. It's just the manpower, it sits, and he has to mobilize the things. That's how now, in this time period, it has been done. Thank you.
Thank you. Thank you. So next I have my question to Ms. Mrs. Aradi Bhosle. So, yeah, see, large Indian companies are putting up large blast furnaces, which will produce hot metal, which primarily rely on metallurgical coke. I'm sure, you know, the Indian scenario, another 25 years blast furnace is going to remain. And, you know, CCUS technologies that can potentially reduce carbon emission, possibly they have not reached technological readiness level to be suitable for blast furnace processes. So how do you think the large steel plants, and we need, you know, iron ore from, we have to make steel from iron ore, you know, as we were discussing, can work towards reducing their carbon emissions?
Okay. Hello. So basically, as all of you know, that blast furnace is around 50% of total steel making process, and that is currently not completely replaceable. So we can see some difference, at least in terms of energy efficiency, then use of renewable energy is there, then mostly switch to cleaner fuel in terms of natural gas, then this hydrogen-based DRI. So these are basic few things we can at least implement to improve the blast furnace efficiency. Because CCUS is not that much cost effective and easily achievable. So it is a pilot projects going on abroad basically. So now it will take some time also to reach here and implement it.
Yeah. I understand JSW is trying to do some hot blast stoves being, you know, electrically heated. Some of these projects are being tried to reduce the carbon emission, I understand. Yeah, yeah.
Lot more places actually. Scrap is of course one of them, then natural gas-based DRI, natural gas getting injected into other processes also. We also have got pilot for, you know, hydrogen-based. There is a plan, the technology is there. Scale will obviously be when the viability is there. That's the only point.
Yeah, anyway, natural gas availability is another problem.
That's a problem. Yes.
Amrita Kandekar, what is the outlook for domestic steel demand and prices in India, especially in light of rising domestic capacities? Will stronger import controls drive sustained increase in domestic prices?
India still is a bright spot in terms of global steel demand, I would say. And, you know, we have a big infrastructure push, manpower, population. So there's a lot of factors on the side of India's steel growth story. And also now interest rates are coming down and there's been GST rate cuts. So that will, of course, definitely give a boost to consumption. But I think at this point, there is a big demand-supply gap. So demand is growing, but supply is growing much faster. So I would say, you know, for steel prices to really regain that kind of momentum, there needs to be more demand, and also, I would say a portion of steel would at least need to be exported. But again, that has its own challenges because of CBAM and the growing protectionism everywhere. So one way would be to really go big on downstream expansions, which I think many steel makers are doing, so that can absorb some of the capacity. And as to the other question on imports, as we have seen, import controls definitely give some support to the market, but it's not enough to drive a sustained increase in prices. And I would say the key is to really, really drive up demand so that it can absorb that excess supply in the market.
Bhatia ji, see, on one hand, production of steel through scrap recycling, it opens up doors towards green steel. We are already. This can also potentially enable steel that can be exported, to countries like US because they are putting a lot of, carbon restrictions. However, there is a general suspicion on the quality of steel produced through induction furnace, both in the country and surely outside India. I myself have seen that. So, there is an opportunity for recyclers through induction route because green steel has a market outside also. So, how do you think this opportunity can be leveraged, by the recycling industry? Any thoughts on this?
That's very true, I think. It's a great opportunity in the global markets, green market. And like air is already doing the same way. So we have one quality, out of gate, one quality. There's no two quality. There's no D, non-D. It's a single quality. And it can be exported even than today. So that is the ultimate, which I understand, green and the quality and the transparency in the data. The three things which I understand is the future.
Yeah, thank you. Thank you very much. So, now to Mr. Mayur Shah. So, I think there is a lot of discussion on BIS standard being revised. I know that. I myself have written some of my comments to the Ministry of Steel. So, there are proposals to make phosphorus requirement more stringent. What are your views on this?
Sir, actually, coming up on the BIS, if you make the material more D grade, you get a premium from a range of 1,000 rupees to 1,500 rupees. So when you make this more stringent coming up for the phos sulfur thing, this margin would be squeezed. Because again, it would be the same issue. You are making up basically 500D or you are making up 550D. That would be a base price. But for the exports, that would be an opportunity when you start exporting those materials to different countries. That would bring up a value addition for the company.
Thank you. I have one more question before we go to the audience. Maybe I think I'll address to Bhatia ji. Some time back, PM addressed, regarding, especially wants to open up the defense sector, shipbuilding, space, where we need, high quality grades of steel. At present, many steel grades are being imported, and because we still have not developed the technology towards those grades of steel. So, and there are also, government is thinking of opening up the defense sector and all those things. So I again see opportunity where, private-public partnership in, Atmanirbhar Bharat, developing high grades of steel, of course, which is a low volume niche market. And I believe, especially again, recycling industries will have a large play because the large steel plant, they operate at 250 ton, capacity heat. But this probably needs much less, 10 tons or 20 ton. So how we can leverage it so that many of these high-end steel can be produced within the country. And that is, again, our ambition, if we want to have our space program, defense, all those things. So any views, yeah, by Bhatia ji or, yeah, please. Yeah, any of you, yeah, please. Any of you, yeah.
So actually, the main thing is we have to import the chrome, or we have to import vanadium for making this high grade of steel, right? So as when we compare with China, this material comes up on a very sustainable price, and you can get huge quantity. Whereas over here, if you ask, so all the big players only would be making up such grades, what we say like HT grade, different grades, right? So this is the scenario where many of the grades are not been made up because the profit margin is squeezed, and you are unable to get the actual price for the product. And at the comparison, the import prices are quite cheaper.
Okay, thank you. I just want to add, when it comes to these high grades of steel, the processing also needs more sophistication. And I do see that there are some alloy steel players who do make from scrap. So maybe, if those players can come with defense agencies, and the process needs to be developed. Again, some discipline in the process parameters and all those things. So I think one can work towards it, and I can tell you that as IIT Bombay academician, I'm also trying to connect some of these people and see such an ecosystem can be, we can bring so that our quality can be improved, and we can make high-grade steel. Yeah, so now let me open up the panel for the audience. So audience, if you have any question, please, yeah.
Hi, good afternoon, everyone. I have actually two questions, one for Mr. Keurshah and one for Mr. Rohit. So, Keurshah, first question for you. I know you announced yesterday during the plenary session that there's investments of a pilot project of monosteel in green hydrogen. Is this something that can be scalable for the entire secondary steel sector? I heard a lot of the panelists speak about how green hydrogen is very capex heavy. So how do you feel that we can make it more cheaply available for the secondary steel sector to use more green hydrogen?
So basically, Zenbai, we are based out of Kandla. So Kandla port right now, they have got a pilot project of L&T for producing green hydrogen. More 30 companies have registered for the green hydrogen project right now. And under the scheme of Ministry of Steel, the main pilot project thing is right now they want to do it on a 100 TPD base kiln. So if we look at the coal price, it's 8,000 rupees a ton. And looking at the hydrogen, is something around 2,55,000 tons per ton price. And the consumption of coal per day for a 100 TPD kiln would be around 100 tons. And for the hydrogen, it would be around 22 tons. But the main thing after the pilot project, when you remove the hydrogen from the water, you generate oxygen. So the process should be with the induction furnace coming up with the BOF and casting. So that would be a long process for the industry. So now we have started up with the pilot project work. And maybe I think so, if it goes success, then it would be a industry boom for the entire nation.
Thank you. Second question is for Mr. Rohit. I know you, in your presentation, you showed about where certain shredders are coming across India and where there's opportunities. GSW themselves announced a large shredder project in western, outside the outskirts of Mumbai. So the question for you is, the current shredders that are already existing, we've seen Tata already set up, they're not getting any feedstock, right? They're not being able to run. So what do large mills like yourself, which are consuming more scrap, going from 5% to 10% in your consumption, you need the local scrap. Where do you plan to get the local scrap from? The concern obviously is you have this large shredder, 200 crores investment, but you're not getting the feedstock. That's the concern. My question to you is, what are some of the solutions and options available to you to actually get that in-feed into your shredder plants?
So apparently I was there at Tata Steel when the shredder was set up, and I was heading procurement there as well when we started to procure scrap to feed the shredders. That was back in 2021. Took about 6 months of ramp up, and post that the shredder there is a typical 55-60 tons per hour shredder. We were able to ramp up to about full capacity. We ran about 20-21 KT per month, and the reason that we slowed down at any point in time was not scrap availability, but it was more of viability and whether we'll be requiring it for our internal consumption or not. So that was the story there. But how did that happen is more important. So what we have we've missed the piece of automation and digital in this entire discussion. We started with an app through which we procured scrap. We're doing a much better and a much bigger and a much more wide app when we are doing this in JSW Steel. The entire procure to pay will be on that app. One is the app. The second part is, when we convert a person from the unorganized to the organized sector, there is a lot of, and somebody spoke about upliftment of the, people, I think, yeah. People actually wanted to associate with somebody like, a large steel maker, because that really, brought him some accolade in the society that he's not just a kabadi wala, but he's actually a person who does business. That is where, lot more aggregation. It's not that scrap is not there. You and I would not know scrap is there or not there. It is basically those aggregators who would know whether it is there or not. It is for us to see how, easy, let's say how rewarding we make it for them so that they're able to aggregate that scrap and bring it to us. So we saw an outshining story there in the north. And I'm sure for the kind of scrap that we are seeing 30 million ton in India today, going up to 40, and probably more that we may not even be aware of. I think, with this approach, this organized sector coming in more significantly, digital coming in more predominantly with not just us, with even the others and the others learning from it. Digital in terms of quality inspection, there has been a lot of discretion on quality inspection. It's been manual in most of the cases. You bring in digital to that. A lot of companies in Europe are doing, this AI-based quality inspection. So you bring that. So people, the more you associate people with rewards, the more, accolades that you give to them, the more you uplift them. I think that is that much more of local scrap you'll be able to aggregate. That's what we've seen.
Just to add to our hydrogen, a pilot plant, I am very passionate about pilot plant. I have been telling that we need pilot plans for our innovation in my presentation also. So one thing I just wanted to tell is, yes, we should look at the cost, but cost is, for a pilot plan, one should not look at it too early, because it is something for the future, because we should be ready now itself. We should start working so that when hydrogen become a reality, we should be ready for that. And I also believe, if we develop our own technologies, design, engineering, etc., it will be much cheaper than buying technology from outside. So I think with that in mind, and also testing our own raw materials and all those things, so the pilot plan should be something we should keep, doing our experiments. Technical abilities has to go up. Then I think price will come a bit later, means that's what I believe, So that should be our vision towards the pilot plan. Yeah. Any more questions from audience? Anybody would like to?
Good panel discussion today. Rohit ji and Ashwini ji, or anyone can answer. How serious the concern for the GST issue on the local scrap buying? I'm going to say, we keep hearing from past 7-8 years that secondary steel definitely have affected a lot, and they are more concerned on the GST purchases. They are not aware that how to, I'm going to say, genuine or ingenuine. When you buy bulk, many vendors you get registered. So how you come across, and what is the solutions for this? We as MRI definitely and IFA are proposing from 18% to 5%. It is not getting resolved at the government level. So that will definitely, if it is done, then definitely it is good solutions for all of us. But then, what is the solutions for you? Point number one. Point number two, second question is along with that, that how the processing of scrap is necessary in the melting of the secondary steel and the primary as well for you, both of you. I'm going to say whether it's mono steel or whether it's a JSW or ARS, please. Thank you.
I can answer that? Yeah. So the first part, of course, I mean, you've hit it absolutely there and correctly. GST is a huge problem, and you know, we've all been associated with it. In fact, the GST intelligence used to invite me. I've stopped saying that they used to interrogate me. They used to invite me for discussions every fortnight when I was in Delhi. So we were trying to find a solution together. Of course, you know, this GST rationalization that we see, 2% TDS reduction and reverse charge mechanism from unregistered to registered is part of the advocacy that we have been doing for years. You've been part of it also, when we were there in the north and now with JSW Steel. I think, you know, this part government understands extremely well. While, you know, there's not been a GST rate cut on scrap in the recent enormous GST rate cuts that we've seen in the other commodity, but I think because the government knows it so well and we know that recycling is important, if the government feels equally, there should certainly be, you know, a time where we'll see reverse charge mechanism coming into scrap. There are challenges because, you know, there is a possibility that people evade tax even there. They might start tagging their finished products as scrap. So that's the concern that the government has, and there are various other concerns along with it. But I think since this movement has started, there'll be, you know, some, obviously there'll be some improvisation over what they've already done today. That's one part of it. Second is, as a, you know, responsibility for the steel maker, what can he do? Traceability is very important. It's not just the responsibility of the government to check traceability. For you also, to whatever extent it is possible, check the traceability whenever you are buying scrap. That's what we've been doing, and we've evolved over that over the last 4 or 5 years. Try and, you know, associate with people who have converted themselves to more organized and better approaches in, you know, complying with GST rather than, you know, continuing with the earlier efforts on that. So that's the first question. The second question on processing, of course, processing, at least for us as JSW Steel, we cannot do without processing. We have our, so for a typical BOF, we have scrap buckets which are about 60-65 tons. You'll not be able to charge that much of scrap. And when I'm saying scrap, it is the external scrap. Had it been DRI, had it been HBI, or had it been the internal scrap, which is much heavier, it is easier to charge. But if you're buying from outside and don't process it, you'll not be able to charge it all. So you are really missing the bus. So in the you know, race for decarbonization, you'll actually not be able to produce the steel that you wanted to produce. So processing is, of course, very important. We'll not be able to do without it. And not just processing for the sake of it, but processing in terms of, you know, having the right bulk density. So for example, shedders, which really comply with, in fact, even are better than the imported ones, you know, 1.1 ton per meter cube, not less than that. Let's say the shears, which very efficiently give us about 0.5 meter length cut scrap, and to the throughput that we want. The balers, you know, anything ahead of 2 ton per meter cube, 2 or maybe even up to 3 ton per meter cube kind of balers. So that's the focus. It's the need of the hour for, you know, for a company like us. Thank you.
Thank you. I think it's time is up. That's what I can see from the screen. So I think we had a wonderful panel discussion, very lively panel discussion. So let me thank all the panelists, and now I would like to, you know, invite Mr. Sanjay Mehta and Zain Nathani from the Nathani Group directors to felicitate you know, the panelists. So,